Alright, section 3.2, a very short section, proof and perpendicular lines. However, you will be very excited to know that we will not be looking at many proofs in this section. A lot of it's just about perpendicular lines. So I know you're all jumping up and down at your homes right now. So first thing is, we need to look at what are perpendicular lines. So perpendicular lines are two lines that intersect at a right angle. So two lines that intersect at a right angle. Okay, so if I draw a picture, so here is one line, here's a second line. Let's call this line line L, and let's call this line line M. We signify that they are perpendicular by putting the little right angle box, right? And we would say that L is perpendicular to M. We use this upside down T. That upside down T means is perpendicular to. Okay, so that's what that means. So we're going to look a lot at perpendicular lines. Remember that this right angle box, right? Remember that's a 90-degree angle. So you're going to do some problems that involve 90-degree angles. Okay, so I talked about that postulate that we have to get back to. So we will talk about it right here. It's called the perpendicular postulate. And again, we're going to do a construction on it in class. So we'll bring it to life, but the perpendicular postulate. And again, we'll use a drawing to describe it. So here is your line. Call it line L. And here's some point in space. Call it point P. So just like the parallel postulate, the perpendicular postulate states that, when you have this situation, only one line can go through P and be perpendicular to L. So there is only one line perpendicular to line L through point P. Okay, so again, if I draw that line in, here it comes straight down. Call it line M, and again, it's going to be a right angle right there. And we would say that L is perpendicular to M. Oh, not capital M. Okay, so there's the perpendicular postulate. And again, we'll do a construction in class. So there's a couple of the theorems about perpendicular lines that I want to draw to your attention. Okay, so theorems, and there's going to be two theorems. Okay, and they really don't have names. We're just going to write them out. Okay, so here's the first one. We'll use bullet points. Okay, if two congruent angles form a linear pair, then each angle is a right angle. Okay, if two congruent angles form a linear pair, then each angle is a right angle. Okay, so let's draw this real fast. Okay, so here we go. Here's our line. Okay, and I don't even have to draw the picture normal. I'll draw it like that. And here's angle 1, and here's angle 2. I'm going to mark them congruent. Just like that. So we know that linear pairs are supplementary. So we know that the measure of angle 1, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We know that. And if they're both congruent, then you have to think to yourself, what plus what gives you 180 that they're the same? And that would have to be 90 degrees. And there you go. So there's sort of your conclusion, right? They're each 90 degrees. So they're each right angle. Okay. All right, let's take a look at the second theorem I want you to remember. Okay. And this is the following. If I don't want the purple, I want the pink. If two lines are perpendicular, then they intersect to form 4 right angles. Right angles. Okay? So if two lines are perpendicular, then they intersect to form 4 right angles. So here's the idea. Here's our two lines. Call them L and M. And they're perpendicular. So we know that one angle is a right angle. Well, you can use a lot of different ideas. You could say that this right angle and this angle are vertical angles, and vertical angles are congruent. So we would know that that is also a right angle. We could use the fact that these are linear pairs, and this is 90, so 180 minus 90 is also 90. And the same thing up here. So we have 4 right angles at that intersection. Okay, so I'm going to bring in an example, and we're going to take a look at it involving right angles. Okay, so here's the example I brought in. All right, example. And let me set the picture where I want it. That sounds good. Okay, so the example is find x. All right. So I hope you can read. This is your x, and this right here is 29 degrees. Okay. So we have to ask ourselves, what can we use to find this? Well, I see this right angle box. That's important. Okay. And look at x. X is right here. Let's trace the lines that form x. There's that one. And there's that one. X is going to be a vertical angle with this angle right here, and that means they're congruent. So we're going to use vertical angles in this problem with the x's, okay? So with the x. So vertical angle. So this is x. And now look, these two angles together form the 90-degree angle. So we would say that x plus 29 degrees equals 90 degrees. Subtract 29, x equals 61. So x, the value of x is 61, and its angle measure is 61 degrees. Okay, so this is basically it for section 3.2. I'll see you in class where we will work on some problems.